We've talked about how voltage and current are directly related. We haven't really talked about resistance. We've mentioned resistance briefly. I'd mentioned that the nichrome wire resists the flow of electrons, the flow of current more than the copper wire. And different materials and different, not even just different materials, but different objects can resist the flow of current more than others. Things that with very low resistance are things like copper, gold, silver. Things with higher resistance are things like nichrome. Okay, so nichrome, it allows electrons to flow through it. It allows current to flow through it, but it provides a lot of resistance to that current. So the resistance is um, what reduces the current. So we saw earlier that there was less current traveling through nichrome than there is through copper. Resistance is the value that resists the flow of current through an object. And wire will have there are a lot of things that determine resistance. It's partly the material, so like copper has lower resistance than nichrome, but it also has to do with the thickness of a wire can determine resistance, or the length of the wire. And so that's why you see wires of different thicknesses used in different places. And and then shorter wires tend to shorter wires have less resistance than longer wires. So we can create a mathematical relationship. We already established that voltage and current are directly related to each other. And since we know that resistance is something that resists current, we can infer that resistance is in some way inversely related to current. We have an equation that describes the relationship between voltage, resistance, and current. It's called Ohm's law, and it's stated as voltage equals current times resistance. Now, the symbol, the symbols for voltage and resistance are capital V and capital R, and those make perfect sense. But you also need to learn that the symbol for current is actually a capital I. And so the equation is written out as V, excuse me, V equals IR. The units for voltage are volts. The unit for ampere or for current is amps or amperes, and the unit for resistance is R. I'm sorry, the unit for resistance is ohms. So V equals IR. That's something that you're definitely going to want to have in your notes, and something that you're going to want to learn and be able to use. That is a very important equation in physics, in electricity. It's called Ohm's law. So think about what it means. It means that it means everything we've just said. If you increase the voltage, then you're going to increase the current. If you increase the resistance, then you're going to have less current. And so we'll do some practice problems to see how this works out. Here's a sample problem. If we have a circuit that contains a battery and a light bulb, the light bulb has a resistance of 3 ohms. The battery has a voltage of 1.5 volts. And we want to find the current in the circuit. We write down what we're given. We're given V equals 1.5 volts. We're given R equals 3 ohms. And we're given the equation V equals IR. We want to find I. So when you solve this equation for I, you divide both sides of the equation by R, you'll end up with I equals V over R. And so V over R, it was 1.5 over 3. And you'll end up with the resistance equals 0.5. Now, zero point 0.5, I'm sorry, not the resistance, the current equals 0.5 amperes. Okay, so this also gives us an equivalent of units, that volts is equal to 1 volt is equal to 1 ampere times 1 ohm. Ohms is the unit for resistance.